Okay, so since my part 1 video, I made some major changes. I'm going to show you the code I worked on. Before, in the input loop, every single frame it had this code. It first had this code that I've commented out. First, every single frame it tried to use the player X1 and player Y, the old location of where the player was at the previous frame. It tried to replace it with the old color, and then it drew the new color there. The new location of where the player was at. It drew the red square. But that code is no longer in use. Instead, it does indeed draw the location of the player every frame still. That's the only thing about this part that's the same. But there's something much different. There is, let me make sure, yeah, I am recording. Okay, good. Instead of having it replace the previous location with the color every frame, I found a method that takes more code but works correctly. Now first let me prove to you that it does work, and then I'll explain how it works. So now everything is pretty much the same as the previous video. You can't move through a blue square. You can go through a yellow square. It goes to the next level. Let's restart this because I'm going to show you. Now this science square, I can move onto the science square, but then when I leave the science square, it's back to being cyan again. And the way I went about that is actually pretty weird. And I'll also show you, I move the green square onto the cyan square, it turns magenta. So now I move it, the green square is back. You see, the green square is back. This square is magenta again. I mean, it's cyan. Never mind, I misspoke. Okay, so yeah, so the player can pass through a cyan square at any time, but it retains its cyanness. The green square can go at any time, but then as soon as you move the magenta square, it becomes a green square again. So yes, and then the green square goes and it still breaks. So everything works exactly as I had intended it to. And I have all 8 colors, which is really super cool. So how does it work? Okay, so here's what it does. It does something very carefully. Each conditional has its own specific code. I had to copy paste a lot of the same code, but it does things only when I want it to. So the other thing was just out of my control. Okay, so here's the deal. So for example, in fact, come to think of it, I just realized something. I'm going to try something. I'm going to try these secondary variables, player X1 and player X. I don't think they're actually used anymore. I may have actually eliminated them. Let's see if it still works. Yep, that part still works, and that part still works. Yep, everything. Yeah, those variables are not actually used anywhere. I completely replaced them, and I'm going to explain how I did it. So I'm going to I'm going to completely delete those variables. I don't need them anymore. However, they might be called in the function putPlayer. Yeah. Okay, so in my putPlayer function, I use those variables, but since I've deleted them, I'm not going to even have them in there. So I was able to delete 2 variables entirely, and I don't need them anymore, and the code compiles without them because it's not keeping track of where the player used to be. Instead, it uses a different method. So, let's go back to the input loop. So, for example, so everything as far as the directions of the code, it hasn't changed at all. But what has changed is we're no longer saving the previous location. So it still checks the pixel to see if moving is allowed. But here's what it does then. And each of these set the target bitmap to 0 because we're going to be drawing to that bitmap. So first, it draws the old color where the player variables of x and y currently is. And then, only then does it update player x and player y with x and y, the locations of where the player is going to be after the move. So each of these do that same thing. They all set the target bitmap to bitmap 0. They all, it's the same copy-pasted code that replaces it with the old color. They all do that, and then they update where the player moved to. And that code is the same. So I copied and pasted a lot of code, but this works as expected, and here is a particular reason why I had to do it the way I did. So, when we move, we move on to a boxed target. Here's the trick is, when I was moving on to the boxed target, which is the cyan square, it was updating the old color, but then it immediately in the next frame, it updated the old location I was at with that, that color. But now it doesn't do that. Why? Because it cleverly replaced it with the old color, which was black, before it updated the location and then stored the old color of where I'm moving to. So it doesn't. It updates that rectangle. It draws that black square of where I moved away from before it stores the cyan square. So by redoing the entire code, I had to copy and paste that same code in each conditional statement, but this means no unintended side effects. It works as expected. And right now, although I like elegant code and reduction of copy and pasting, this was the quickest method, was to copy and paste. And there is another good reason, though, why this might actually be the best method. So, here's what it does. Now, remember the magenta square means a box placed. So, here's the deal. When the box is placed, it, instead of setting the old color equal to whatever that pixel was at that location, this time, instead of box placed, it sets the old color to box target, which means it knows that the old color, the color that was supposed to be at that square, was cyan, even though it was magenta at the time. So I did a rewrite, and now it's a clever switch. And it stores that old color, not the old color, because the old color would be magenta. It stores the really old color of cyan, which is what that square was before we moved the green square on it and turned it magenta. So then the trick is, because the old color is cyan, then as soon as we move that magenta square, we move the, let's see, where was it? Yeah, because I'm trying to remember how I did this. Okay, yeah, because first, I got lost here. So, right, so when it's boxed placed, yes, it's storing the old color. So then, what does it do? As soon as any operation where the square moves, whether it's moving to a black space or whether it's moving the the green square, if it's moving a green square onto another black square, regardless, what it's doing then is it is restoring the old color. So it restores the old color. So like, let's say if whether I'm moving to a space, because the next space, or if we're moving a green square to another space or to a blue square or anything, no matter what we do, it correctly restores the old cyan color. So rather than always storing the color, in most cases it simply is storing the old color of the target location, but well, it's not doing that in the case of green squares. It's very customized. So for example, when we are, okay, so let's say we have a box that we're moving, that there's a box. What it's doing is it then gets the pixel value of the space where the box is going to be moving to. So in other words, if that square is black, or if it becomes black because we erased a blue square that became black, then the old color becomes black again, meaning the next move replaces the red square with black. So it's clever. I eliminated 2 variables. I had to copy and paste some code, but it does work now. So now my code works completely as intended. And then what I'm going to do is I think I'm going to show you how I back up my code, because I've never been able to show this before. Okay, let me make sure everything looks pretty. Yeah, well, it's not going to be perfect, but so, and also I have 4 files now. I have the input loop, which is still the biggest file, a little bit bigger now that I copied and pasted all that code. And then we have main.c, which is slightly smaller because I have a new file. Okay, so this is the one that has my color comparison function, but also the functions for putting the player and putting the box, putting a target, putting an exit, putting a breakable box. So everything is so cool. So yeah, we never are putting the magenta square. Yeah, let me look back. See, the magenta square, the box placed, is never inserted into the level because it's not a box placed until we actually place the box in that square. So here's what I'm going to do. So I have all of these, and the code is correct. Let's just check it one more time. Make everything works as intended, and the green square goes, it becomes magenta. We can move it away, it's green again. We can break the blue box, and then we can go to the next level, and then we can move the green squares around however we like. We can restart the level by pressing A and pressing escape. The program ends. It's perfect as it is. The program is perfect. All I need now is to design levels, but I'm too tired to do that tonight. I've probably spent 3 or 4 hours working on this code. There's the near 2 hours of my first video, and then spending another who knows how long, and then recording this video. So I've spent an enormous amount of time on recording this programming session. One more thing though. Let's cat make file. There are several things. I have a command to back up the source, and it's a tar command. So, okay, back up source. I even have one to back up frames if I want. Oh yeah, I have to do make backup source. It's a make command. Make backup source. And then, see all of that? All of those files became an archive named sokoban.tar.gzip. And I'm going to show you this is my my tar folder. And see the tar folder, notice, okay, this is the September 11 tar file. And inside here we had the 3 source files and a make file. Now this new one that I just made is the 13th. And it basically is, yeah, it's the same thing, but it has 4 source files and the make file. So the make file that compiles, that I use to compile the code and manage the frames and stuff like that, is part of the archive as well. And and that tar command is super useful. So yeah, it's just super useful because the tar command is basically, it makes like zip archives. And so if you just look, I'll show you, the tar command is great because it creates an archive and I can extract it with 7-zip or other types of programs. There's also commands from the command line to unzip it, to uncompress it and restore the original files. However, as it turns out, I almost never need to do that. There are commands, I have a file somewhere that tells me that, plus there's online tutorials. But I spend a lot more time backing up the files than I ever do extracting them, because really the truth is I only need to extract the tar files if my hard drive is wiped out and I lose access to my code. So I'm going to show you, okay, now that I have bbm sokoban.tar.gzip here, okay, so I'm going to have, this will be 9/13/20. So today's date, and oh crap, it's 2:47 a.m., 2:49 now technically. So I'm going to show you, I'm going to back this up. Okay, I'm going to exit my terminal here, and then I'm going to upload. I'm going to go to my SourceForge project. I'm going to stop it from doing that because it tries to load my email, but I don't want it to do that right now. Usually that's where I start, is my email, but in this case I'm going straight to my binary bitmap project. And even though this project is technically not my binary bitmap source tree, it's along the same lines of graphics programming, and eventually I want to create a BBM library that interfaces with either SDL or Allegro, because my own code, which is cool, it loads and saves images files. I can manipulate images, even draw polygons, but it can't create a window on the screen and get user input like SDL and Allegro can. And SDL I could have written this game in SDL, and if I want to make a total rewrite later, that's great, but I've spent like 12 hours on this game so far in Allegro and it works. So that's good enough for me for right now. Although if somebody was to pay me to design games, I would use SDL, Allegro, or whatever else I was capable of doing. So I'm going to add this file. I'm going to add this file, which is September 13. And also, I've been having an interesting time recently. Oh, notice this. Yeah, I have several branches. I never even finished this sentence. That's weird. Yeah, but yeah, I have BBM, the original. It's all just C code standard library. I have a C++ version that doesn't have as much, but I was experimenting, making a class. I have the Allegro one, which is what I've been using for this game I'm making. maybe I'll have an SDL branch of BBM do a special thing. And then I even use the Rust programming language. But you know what? I didn't like it. I like C and C++ because I'm used to them. Rust might have its merits, but it hasn't become mainstream enough. And even though I actually bought a $25 book, I have not taken the time to learn Rust because right now I just want to write programs that work, and I'm not too picky about which library or programming language. But I'm a C programmer. It works for everything, although I like other languages too. So anyway, this has been my programming video. I hope somebody's enjoyed this and learned something about programming with Allegro, because if you're interested in using Allegro to make games, you see that it does work and that I just successfully made a Sokoban clone. It only has 2 levels, but it has all of the elements that are needed, except there are a few things that I might need to change in the future, such as it doesn't have any code to go to the next level when all of the boxes are moved to their target. It doesn't have code for that, so it's still a work in progress. But hey, it's a nice game. It lets me take user input and do things, as you just saw, for well over 2 hours. So thanks for watching. I hope somebody learned something from this. Goodbye.